speed and velocity. So speed is defined as the rate of change of distance with time. Speed has no sense of direction. It doesn't have direction. It is a scalar quantity. While velocity is the rate of change of distance with time in a specified direction. So that is the difference between speed and velocity. Speed doesn't have direction, while velocity, it has direction. They have the same unit, meter per second. Both of them are measured in meter per second. Then uniform speed and uniform velocity. Uniform speed, a body is said to be in uniform speed when it covers a distance in equal time interval. No matter how small the time interval may be, the speed is said to be uniform speed. It's said to be uniform speed or constant speed. Likewise, when a body covers equal distance in equal time, no matter how small the time interval may be, that body is said to be in uniform velocity or constant velocity, but in a specified direction. And that is the difference between speed and velocity. The difference is that speed doesn't have direction, while velocity has direction. So that is the difference. They have the same units. So, for example, a motorcyclist, when a motorcyclist passing through a road junction due east for 8 seconds, and he covered a distance of 40 meters. So the uniform velocity of the motorcyclist is the total distance covered divided by the total time taken. The total distance covered is 40 meters, while the total time taken is 8 seconds. So now 40 divided by 8, we have 5. So 5 is now the uniform velocity of the motorcyclist. 5 meters per second is the uniform velocity of the motorcyclist. The motorcyclist covers a distance of 5 meters in each and every second. That is the meaning. In each and every second, he covers a distance of 5 meters. That is the meaning of 5 meters per second. So that is the uniform velocity of the motorcyclist. So now the definition of uniform speed and the uniform velocity. So uniform speed is when a body covers a distance, covers equal distance in an equal time, no matter how small the time interval may be, but direction is not involved. There is no direction there. We don't know the direction of the body. So that body is said to be in uniform speed or constant speed. Likewise, when the body covers equal distance in equal time, but in a specified direction, no matter how small the time interval may be, that body is said to be in uniform velocity or constant velocity. So this is the difference between speed and velocity, as well as difference between uniform speed and uniform velocity. So the next thing we have is distance or displacement time graph. So distance or displacement time graph is a graph of the distance or displacement covered by a moving object against the time taken. And here are the illustrations. In figure 1, we have the uniform speed and velocity, where the body starts from the initial point up to where the body stops. The body has the same velocity or the same speed. So this graph is a graph of uniform speed or the uniform velocity. While the second graph, which is figure 2, is non-uniform speed or velocity. As you can see, the body, the motion of the body is not in straight line. This body has some curves. It has some curves. That means the motion is not in straight line, and therefore the motion is non-uniform speed or non-uniform velocity. So that is the difference between uniform speed and the uniform velocity. And this illustration shows, this graph shows the difference between uniform speed and the uniform non-uniform uniform and non-uniform speed and velocity, and non-uniform speed and velocity. So this is uniform speed and velocity, and this is non-uniform speed or the non-uniform velocity. So that is what we have today. I'm going to stop at this point, and to meet in the next one. Now we meet in the next one. So have a nice day.